Hey there, Algebra 1. So earlier this year, we graphed what was called linear functions. And I like the name linear because it looks like a line and linear sounds like line. And we used vocabulary like slope, y-intercept. All right, we had a whole bunch of these cool vocab words for our linear functions. Now we've moved on past linear functions and we've moved to quadratic functions. So I'm here on sentence number 2, and when you graph a quadratic or a degree of 2, so anytime you have that degree of 2, you create a parabola. And a parabola is this U-shaped graph. So quadratic, we're now graphing parabolas. So parabolas have their own vocabulary that we need to use. So I'm going to switch to a different color here. And there's lots of different vocabulary included with a parabola. Here's one graphed for you, and it says y equals x squared minus 4x plus 3. So one of the first things that we like to talk about is what's called our vertex. So this point down here is our vertex. I'm going to go ahead and I'm going to label it with this blue color. Now for this example, it happens to be the point 2, -1. However, your vertex might be a different point if it's a different parabola. So let's go ahead and let's define it. So the vertex is the lowest point, also known as a minimum, when the parabola opens up. Opens up. And what I'm talking about this is that we have this kind of U shape, just like we have on this graph, and it's this lowest point. However, I'm going to switch over to a different blue because sometimes it's the highest point, also known as the maximum, when the parabola opens down. So sometimes this is flipped over and it looks kind of like a arch, and that would be the vertex up there on the highest point. So this is our vertex, and again for this example it's the point 2, -1. So the vertex is pretty important because it's part of what we call our axis. Oopsies. Axis of symmetry. And the axis of symmetry is this dotted line that we have going down right down the middle of our parabola. So for us, in this example, our axis of symmetry is x is equal to 2. Now if you'll notice here, the axis of symmetry always matches up with the x value of your vertex because it divides the parabola. Oops, I can spell, I promise. Parabola into 2 symmetrical parts. And it goes through the vertex. So it's this dashed line that goes right down the middle. Now, sometimes we refer to our axis of symmetry as AOS, just some shorthand there, but you can make a note of it. So those are our vertex and our axis of symmetry. Very important parts. However, some of the also important parts of this parabola are roots. Now, we've talked a teeny tiny bit about these guys. Your roots. I love our roots. Because what I love the roots is that they are the x-intercepts, also known as the solutions to the quadratic when y equals 0. So for us up here, we can just look at our graph, and these are the points 1, 0, and 3, 0. However, if we wanted to go ahead and factor this guy, we would say y is equal to x minus 3 and x minus 1. And if you'll notice here, these guys, these roots here, are the solutions right here, which is super cool about our roots, and that's why I love them. Now, last step to our quadratic here is, of course, what we refer to as our y-intercept. I'm going to make it nice and big over here. So our y-intercept, and I love our y-intercept because it is the constant, so c in our standard form. So for us right now, it's the point 0, 3. And if we look at this standard form, we have a 3 right there and exactly right there, which is pretty cool. So those are all the parts of our parabola. Now you can go ahead, you can stay with me and copy this next part down, or you can just watch because this is exactly what your homework is going to look like. All right, if you'll notice here, I have these graphic organizers. We have a graph that we are working with. We also have some standard forms and our root forms that we're working with. So we just need to figure out the rest of this. So that y-intercept, number one, we can always look at our graph here. And if you'll notice, I'm filling it in with blue. And it is the point 0, -3. But what I'm also going to show you is that this -3 should match up with that. And it does. Okay, I'm going to erase this over here because we're going to get confused on our blue. I'm going to move on to green with this one. And we can look at our graph and figure out that our roots are where it's crossing the x-axis, meaning that they are the points -1 and 3, 0. Now I'm just going to do a double check here. Are these kind of matching up with my root form? And they are. If you'll notice, they are the opposite from these numbers in here. So a -1 and a +3. Okay. Our axis of symmetry, I'm going to switch to pink. And I'm going to draw this in on our graph here. And it's this line that goes right down the middle of it. Now this is going through the point of my vertex down here. I'm also going to fill that in. So I'm going to start with my vertex because it's a little bit easier there. So my vertex is 1, -4. And this parabola is opening up, meaning that the vertex is a minimum. Now, here's one of the cool things is that this number should be exactly the same. So that x value in my vertex is also x equals 1 for my line of symmetry. Okay, then we're going to jump to domain and range and just a little bit of review. So this is way back, I think chapter 3, when we talked a little bit about our domain and range. So I can use any number that I want for my domain, any number at all. However, my range, if you'll notice here, I can't go below 4, meaning that y has to be greater than or equal to, -4 on this guy. So y has to be greater than or equal to -4 because I'm working with all these values up here. So now we're all completed with this graphic organizer. You can start to see how some things start matching up, including this -4 should always match the y value in your vertex. Okay, let's try one more over here on this other guy. So again, we had this standard form and our y-intercept. I'm looking for that constant. So this is going to be the point 0, 4. It matches up on my graph and with my constant. It works out for us. Now for my root form, I didn't fill it in for you. Sorry, what color did I use for roots? Green. I didn't fill it in for you. However, you can always look at your graph. So those are the points, -2, 0, and 2, 0. However, if we also see that we factor this guy factors into, first we need to factor out I'm going to write it up top here, a negative, because we like to work with a positive x squared minus 4. Ooh, that's a ding dong, difference of squares. So x minus 2, x plus 2, and they do match up with the roots. Okay, going on to this axis of symmetry in this vertex. Doesn't matter which order you like to do it in. I like to go ahead and I like to figure out the vertex first. And if we'll see here, our vertex and our y-intercept are the same point. That's okay, they can share. And then I'm going to go ahead, I'm going to fill in this value right here because it should always match. Now this parabola is opening down, meaning that the vertex is a maximum. And I'm just going to double check my line of symmetry. Yes, it is the point x is equal to 0. It is the y-axis. Now here's something pretty cool. Any domain, you can always go ahead with a parabola and fill in any real numbers, or negative infinity is greater than x, less than x is less than infinity. However, the range on this guy now, I'm working with numbers that are less than or equal to, oops, turn that around, less than or equal to 4 for the range. And I'm just going to double check that this number is the same as my vertex. It is, to check those out. So some of these helpful hints here is that you're always going to go ahead and you are going to check that your vertex x value and axis of symmetry match. Always make sure that those two match. Double check that your constant and y-intercept match. And the last thing is that your roots and standard form should match. Oops, sorry, roots and your root form should match. Awesome job, Algebra 1.